Okay, this question is giving us a dot plot and asking us a whole bunch of statistical information. So bear with me, it's a long question. Hopefully I can make it all the way through without making many mistakes. There's lots of little pieces of information and different learning targets all in this one question. So it's a big question. First of all, you see a dot plot where you see these dots represent how many of each of those values. And you can just generally see the shape, which is one of these questions down here for what we consider the SOCS of the data, SOCS. Right, so you can generally see the shape right now. You have this value that's way out here, and because of that, that's going to change what our shape is. We're going to start with that right away because you can see it. That's going to be considered skewed right because of that outlier, which is way out there on the right. We're going to be talking about how to actually calculate your outliers with your cutoffs here in a moment, but I mean, for right now, that we can pretty much tell that an outlier is way out there, so that is going to be 24. Other key things I have as far as notes in here is what each of these things are. IQR is Q3 minus Q1. You get all of this information, the median, X bar, all that sort of stuff from your calculator, which we're going to go over here in a moment. But you also have the upper cutoffs and lower cutoffs. This is one of the areas where the number one mistakes or most common mistakes is calculating cutoffs, and then how does that affect your box and whisker plot down here at the bottom. So let's just get right into it as far as the data piece of it. You're going to go into your stat menu, and I've already got the data in here just to save time in the video, but you're going to put all this data in here for the amounts 4, 5, 6, 6, 7, 7, etc., and that will be your total data values, and you see that we have 20 different data amounts or 20 data points entered, and that is how many the n is up here where it says n equals 20. From there, you're going to hit that stat button, and then you're going to arrow over to where it says calculate, and you do want to calculate the one var stats, the very first one. And the way this calculator is set up, I'm just going to hit enter. You see the list is L1, that's where I just entered those, so that's good to go. And I just hit enter, and the way my calculator shows it, it's all right there. So we have a lot of information right away just from this one variable statistics. The very top one is X bar, and you can see that X bar is your mean or your average. And so the X bar would be 9.05. And the mode is what happens most often. And so you see that we have 4 8s and 4 9s. So there are two different modes here. So you have 8 and 9. Other thing I could talk about right now that doesn't use the calculator is this information over here. The data type would be, it's going to be quantitative because we're doing a bunch of quantitative work. Quantitative, I can spell it right. Quantitative. Your variable is what your data is. It's the push-ups or the amount of push-ups. And the individuals who we're getting them from, it's a fitness challenge. So maybe students, but we'll just say people in challenge. Could be just people, but I'm just looking at the chart above to make up what this individual is. Individual in general is what or whom are we getting the data from, and the variable is the data itself, so the number of push-ups. So that's why it's quantitative. Okay, going back to the calculator, you have on the far left side, you have what we consider our 5-number summary: minimum Q1, median Q3, and maximum. And so that's all right there in our calculator already. And so you see that your minimum is equal to 4. Our Q1 is 7. That's your first quartile. Median is 8.5. Q3 is 10. Your maximum is 24. So there's your 5-number summary. The IQR is defined as Q3 minus Q1. Right? That's going to be what's coming right here in this width. So the IQR is going to be 10 minus 7, which is equal to 3 in this scenario. Let's put some numbers into our box and whisker plot down below, as they're clearly labeled for you. Q1 is 7, median is 8.5, and this is 10. And so, as your teachers have said in class, is that this is just the best way with our homework entry, the way we can figure out how to get this entered in there. Not every box and whisker plot is symmetrical, but is good enough for us to help us figure out what our lower whisker and upper whisker is. These whiskers are data points. And then outliers are things that are outside of these cutoffs. And so you can see here your upper cutoff is going above this right side, so Q3, upper cutoff, and then you're tacking on your IQR. Remember, your IQR is the distance of this box. So from 7 to 10, the distance is 3. So we're taking this Q3 and we're adding on 1.5 times 3 to bring us up to that top value. So in this case, that would be 10, and then plus 1.5 times 3, which is 4.5, so this is equal to 14.5. The lower cutoff is going to be starting from Q1. Q1 is 7, so this is 7 minus 1.5 times 3, which is our IQR, and so that is going to be 7 minus 4.5, which is 2.5. So that means our cutoffs are like down here. Here's where 2.5 is. And we have 14.5 is right about here. That's where our upper cutoff is. Any data value which is above that would be considered an outlier. Clearly 24 is, so 24 is your outlier. But where the mistake comes, the students often put then 14.5 as the upper whisker, and that is incorrect. Upper whiskers are your data values. It's the last corresponding data point, which is not an outlier, so this would be 12. Your lower whisker is your last value that's not an outlier. There are none on the bottom, so D, N, E, and then this is going to be then 4. So that gets our box and whisker plot, and we'll come back to that on the next set of questions. Let's finish up this general data collection. We've already started with the socks of the data: shape, outlier, center, and spread. The center is the median, so the median is given to us already. That is 8.5, and the spread is just a list of min to max. So that's 4-24. But the range is when you actually do that subtraction, so that would be 20. Right? So that's why I have these kind of quotation marks around that. Finally, we have standard deviation, which we'll get to in a few parts here. That you see on the calculator, we have SX and you have this theta X. S is for sample. So if you have just a sample of people, sample of things, that's when you use this. So that would be 4.07. And population is if you have everybody in the population, which would be 3.97. So that's that first set of all of that particular data and that box and whisker plot. The next part of the question wants you to use the box and whisker plot. I've already got it filled in here to answer a few questions. Remember the box and whisker plot, the purpose of it is it gives you your quartiles, and quartiles are percentages. So that means there's 25% that's going to be less than Q1, 25% that's between Q1 and median, another 25% between median and Q3, and 25% that's above Q3. So when we ask you these questions on here, what percent of students can do at least 10 push-ups? Well, we see 10 is right here. 10 is right here with your Q3, so at least means more than 10, so that's how many percent are above, and so then that would be 25% can do more than 10 push-ups. And then how about what percent can do no more than 10? So 10 or less, or 10 or less, so that'd be 75%, because that's everybody else. And if a student is in the 25th percentile, that's the first quartile, that means they can do Q1, that means they can do 7 push-ups. 7 push-ups. So that's how you use a box and whisker plot to talk about percents of a population. All right, our next plot is our stem and leaf plot here. And so stem and leaf plot is where you have the stems and the leaves. Stems are the first digit. Leaves must only be 1 digit. And so we have values that go from 4 to 24. So that means that we're going to have 0, 1, and 2 to the left in our stems. And then that means we have 0, 4, and then you start listing 5, 6, 6, 7, 7, 8, 8, 8, 8, 9, 9, 9, 9. Ooh, lots of those values. And then in the ones, we have 1, 0. So that's 1, 0 is 10, and then another 10, and then 11, and then another 11, and then 12, and then 24, right? So that's just this number right here. And you can see this is a good example as to why the data would be considered skewed right, because it's all kind of just tailing off here. Some students have a difficult time with the key. That's just saying, like, what does, if there was a 2.5, which there isn't in this data, where would it sit and what would it look like? That would just mean that there would be a 2 on the left. I'm going to leave myself a little more space here. That means there'd be a 2 on the left and then a bar and then a 5 on the right. So just like this 2 and then a bar means 24. If I wanted 25, that's what it would look like. And there's a bar key on your computer that you can use. All right, keep moving. We have a frequency table. Another spot that students often make mistakes is creating the intervals. And you see I've already got some notes here. The minimum is going to be 4. The maximum is 24. And as my notes say, the minimum must be a multiple of 5, and 24 must always be rounded up. So that means that 4 has to be rounded down actually to 0. Make sure you're rounding down. I'm going to put a note for that. So round down, right? And then this one already says round up. So that means that this is going to be going to 25, right? So those are our min and max. That helps us find out our width of each of these intervals. So you're going to do 25 minus 0, and you divide by 5, because it says 5 classes right there. So max minus min. So each are going to be a width of 5, and you're going to start at your minimum. So that means this is a 0 here. But then what I recommend you do is start filling in the rest of the first values. You add 5. You're going to add another 5, add 5, and add 5. And then you go and backfill in the rest. So this is 0 to 4, 5 to 9, 10 to 14, 15 to 19, and 20 to 24. If you count up those as actual data values, that creates 5 data values. Then you can fill in the frequency, how many there are. So that's the key thing here. You got to get this part of it right in order to get the frequency right. And min and max is a piece. There's lots of ways to create histograms and frequency tables. This is just the way that we do it here with our students and with our class, just to make it quick and fast and not need any advanced calculator work. So that helps us create our frequency table. From 0 to 4, there is only 1. From 5 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then in 10 to 14, there's 1, 2, 3, 4, 5. There's none in 15 to 19, and only 1 to 20 to 24. And then, so like, you're not asked to make a histogram, but just to quickly show you, this would be a height of 13 for this. Then you have 1, which is just like right here. And then you have 5, you have 0, and then you have 1 again. So that's what that histogram would look like if you were to have to draw it out. And so again, you can see that it is skewed off to the right. Finally, we have our standard deviation part of the question. We already got the data here, your standard deviation sample versus population. Here it's asked us to round to the nearest whole number. That just helps your calculations. And so the mean is now 9, and now it specifically states the population standard deviation. That creates this bell curve if you have a symmetrical set of data, which ours isn't quite. It's skewed, but a lot of it is symmetrical. So you have this symmetrical bell curve, and then what that means is that our center of it is 9. I'm going to do that in red, so hopefully you can see it. Right, there's 9, and then you just keep adding 4. So 13, 17, and 21. And you subtract 4. This would be 5, 1, and then there's not really going to be any negative numbers, but I guess technically, we'll just keep on doing the math because you're not going to do negative push-ups. But that's how this works. So when a question asks you how many students can do at most 13 push-ups. So that means at most 13 push-ups, so no more than 13 push-ups. That means you're going to add up all of the push-ups that are less than 13. And you can see 13 down here. So you add up all of these percents. So these percents match up, or what that means is what percent of the population can do between 5 and 9. Apparently 34%. What percent can do between 9 and 13? That's apparently also 34%. That's what this normal distribution tells us. So at most 13 means no more than 13, so you're going to add up all of those. So that'd be 68, because that's 34 times 2, plus 13.5, plus 2.35, plus 0.15, and so your answer would be 84%. Right? So that means that 84%, oops, get my pen back here. 84% can do at most. And then finally, according to the population standard deviation, if a student can do only one push-up, they are blank standard deviations below the mean. So one push-up you can clearly see is right here. That's on one of our marks. So how many standard deviations below the mean? That's 1, 2 standard deviations below the mean. So that would be how you finish up that part of the question. A lot of information there, but hopefully, from start to finish, you can follow along and put